Hi, and today we're looking at a case study of the Serenity building at 16 Freeman Road in Chatswood, which has done both heat pump and solar. So Serenity is an example of an apartment block with 44 units, and it's harnessing two types of renewable energy. It harnesses air temperature, and by means of using a refrigerant, converts as air temperature into heat, which is transferred into hot water. And it also has solar photovoltaic cells on the roof creating electricity, which are used to run the electric heat pump. So the 30 kilowatt solar system was installed in 2021. And when they installed this solar system, they purposely oversized it for the future proofing of the building, knowing that they might have EV charging coming in the future and also installing a heat pump to replace the existing solar thermal / gas hot water service. They had solar thermal panels on the roof for hot water, but they had an abundance of roof space, so they didn't have to actually decommission those old solar thermal panels. They could just leave them up there and still fit a 30 kilowatt solar photovoltaic system on the roof. This is the 30 kilowatt heat pump with 2,400 litres of hot water storage, which was installed in 2022. The heat pump is from Mitsubishi and it's called a Q-Ton, and it uses CO2 as its refrigerant. And here's a photo of Brian Peck, who's the property manager, with the four 600-litre hot water storage tanks. They also have a small electric booster tank, which allows hot water to be made during the night time when they don't want to run the heat pump to keep noise down. So the heat pump is located outside the premises with access to fresh air, and there's a control pad which receives data from two sensors on each hot water tank. So for example, you could see on the control panel at this point in time, 70% of the water in the storage tanks is at the target temperature of 65 degrees, and that fluctuates throughout the day. So the strategy to minimize cost of producing hot water and minimize noise from the heat pump has a number of prongs to it. First of all, using a CO2 heat pump with a high coefficient of performance, a COP of 4.3. So basically you get 30 kilowatts of output, but only requiring 6.98 kilowatts of electricity when it's running. The target output temperature is 65 degrees for the hot water. The heat pump could be made to go hotter than that, but there's no need. And they're able to set targets for the percentage of hot water at different times during the day. So for example, the target at 7 a.m. might be that 10% of the capacity of hot water storage is heated to 65 degrees. And this increases from 11 a.m. when the building's producing excess solar power. They'll run the heat pump at 100%, get the target of heating all the hot water up to in the storage up to 65 degrees. And they've also got a peak cut function, which allows the heat pump to be throttled to 40% of its speed, which further reduces the noise by about 8 decibels between 10 p.m. and dawn. The aim is to not run the heat pump at all. And they've also got a timer on the hot water return loop. So throughout the night, they'll only pump water through the reticulation loop around the building for 10 minutes out of every hour. And that'll keep the pipes warm, but it also will reduce heat losses from circulating that water through the night when not many people are using it. So the final thing is they've extracted themselves from the Gemina hot water meter reading monopoly. Prior to this, they had the gas hot water system. They had Gemina hot water meters, which metered the hot water in litres, which goes into all the individual apartments. After transitioning to solar photovoltaic and heat pump for hot water, they're decommissioning the hot water meters, and the costs of hot water will actually be paid through strata levies and will not be metered on a per lot basis. So now we'll have a look at some footage from on site. Introduce, this is Brian Peck, and we're at 16 Freeman Road in Chatswood, and this is the new heat pump system, and Brian's just going to show us through the control panel, which is a Mitsubishi
heat pump.
Yeah, so I'll just explain. That sets the target output temperature of the heat pump. We have it set to 65 degrees. You can go up to 90, but this is a percentage calculation that it does. On the storage tanks, it's got temperature sensors, 2 temperature sensors. So there's 8 sensors go into a computer out in the heat pump, and it computes how much, what the current capacity of hot water is. So it's now saying it's 70% full of hot water. And if you look at the bar graph, it shows you hour by hour. And you can also look at yesterday's. So that's yesterday's, that's today's, and that's the current thing. Now what you can do, you can manage when the heat pump runs, and we have some specific requirements that cause us to set a schedule. So you can hit that says look at the schedule, and we're going to look at the weekly operation pattern for all days. You can't vary it by day, but so what you do is basically there's 8 time slots, and what you do is you can't vary these infinitely, but you can decide what the boundaries of those time slots are and what your target percentage is. So what I'm going to do is I'm going to start at midnight. So from midnight to 7, we want 10%. We don't want it to run at night if we can avoid it.
And that's to keep the noise down.
Let's keep the noise down. We have a unit that's right next to the external unit. To manage that, we say between midnight and 7, we're setting the target percentage at 10%. So it generally will not run. If for some reason it gets completely exhausted, it will kick in, but we generally have that avoided now. Between 7 and 8, we say go to 40%. So if for some reason we're below 40%, okay, kick in and get some more hot water in the tanks. And I'll explain a little bit why we want to do that. Because we have solar power, we want to run during the middle of the day when we have solar power and avoid running when we don't. So at 8 o'clock, we're going to drop to 20%. So from 8 o'clock to 11, we're going to run at 20%. And so the idea there is that we've been off all night. From 7 to 8, if we need it, kick in. Try to go between 8 and 11 without running.
Yeah.
Now 11 o'clock, we got solar power, no question.
Yeah.
So from 11 o'clock to midnight, 100%. Go for your life.
Use as much electricity because most of it's all free electricity.
Well, in the day, of course, we have solar power. It's free.
Yeah.
I have tried reducing that percentage in the evening. The problem is the evening is our peak time. And what happens is it reduces the storage that we have by midnight, and it can't go through without turning on before 6 a.m.
Okay.
Now, there's one additional thing here that we take advantage of. There's something called peak cut. And just only the line 1 there. Between 10 a.m. and midnight, we use the peak cut feature and we say 40%. What that does is it slows it down and it makes it much quieter.
Okay.
So it's still producing some hot water, not quite as much as it would have at full speed, but it does much quieter. It's a good 8 decibel drop.
Right.
And it's pretty quiet now, but since I've been doing that, it's still running between 10 and midnight, and our next door neighbor hasn't even noticed. Those are the standard controls that we have.
Okay.